All right, this one is a fairly short lecture, lecture 36, common oxidation reduction reactions. The first thing that we need to know is be able to pick out what reactions, they're redox reactions, but what kind. So if we look at, we have combination, decomposition, displacement, and combustion reactions. Now for this first one, this one is a displacement. I'll just write down the answer first, and then this is a displacement reaction or a single replacement reaction. They're listed above. Zinc is, it's as if hydrogen and chlorine are dancing together, and zinc comes in and cuts in and takes the chlorine away. So it's a single replacement because there is no, zinc doesn't give anything away. It just comes in, steals the chlorine, and goes off, and the hydrogen is left alone. So it's a single replacement rather than a double displacement that we see with the non-redox reactions, the acids and bases types of reactions where there's or precipitation reactions where there's a trading of partners. You know, think along lines of a dance. So we have hydrogen and chlorine together, zinc comes in, displaces the zinc and displaces the hydrogen and takes the chlorine. So that's a single replacement or displacement reaction. We see oxygen and we see CO2 and water given off. This is a combustion reaction. A lot of times they'll also put in, just to verify that it's heat, you can also put in light as well. When you see this, this reaction can be done in a fuel cell. It can be done so that you don't see a combustion, you don't see the fire or the heat. But generally when you see a organic compound in oxygen, you're talking about a combustion reaction. The big key here is CO2 that's given off in water, and then oxygen as one of the reactants. Here we have mercury 2 oxide, and it breaks up. So since it breaks up, that's decomposition. Now, notice there's a 2 here, but it's just one species breaking up into 2. And it can be one species breaking up into 3 or 4 or 5, but it's one thing breaking up into more than one thing. So it's just falling apart. That's decomposition. Then we have calcium and bromine come together to form calcium bromide. So this is a combination reaction. It doesn't have to be just 2, it could be 3 or more, but usually it's 2. Getting 3 or more things to come together into one, and it has to form into one component. We can have 3 or 4 or 5 reactants, but generally they form several products as well. Here it needs, everything has to come together into one species. And that's it.